Okay, so hello everybody and welcome back. So today I'm going to show you how to do an advanced spline with the correct squash and stretch. And in order to do this, we are going to implement a little bit of math, and we're going to use power math. And if you are a little bit rusty on that, I'm going to do a part 1 series that we're going to understand what kind of math this is. And then that's the part 2 where we implement that into our Maya rig as soon as we've made a quick spline. So yeah, we're gonna make the spline in part 2, and we're gonna add the math knowledge in part 2. So yeah, let's get to it. Okay, so I'm just gonna give you guys a very brief look about what it is that we're trying to achieve here. So this is basically the file as I finished the video. So here you go. So if you take a look at the joints here and at the pipe, basically. As soon as I pull that up, it squashes, it stretches with some volume preservation. The cool thing about this setup is though, that it's not just based off like one value coming into all these joints. They actually increase and decrease compared to where on the chain I am. So you can see this chain is now at, let's see, here's a 1.987, and the one next to it is, sorry, we're gonna go one down, so that's on 1.1. So if I take these values here and set them all to 1, it's gonna have an equal value coming in. However, I can now control this and release my rig with these values already pumped in. So if I say 1.125, 1.125 and 1.125 or 15. You can see I get this, and I can increase and decrease those values. But the cool thing about it is that when you're in 0 position and you're not stretching your spine, all the joints are still in 1, which means that we can skin to these joints, and that's brilliant. So yeah, go into the tutorial or continue watching, and you'll see how I set that up. So yeah, good luck with that. Alright, so in this short break of Overwatch, I'm gonna show you guys how to do a little bit of math for Maya. And the first thing we're going to open up to here is power math, and I'm just going to quickly explain the basics of it, so when we go into Maya everyone has an idea of what they're doing, because I don't really like just showing people how to. I want them to understand why stuff is working. So in this case we're just going to understand a little bit of power math, and this is the basics of it. So first off, here we got a base, and this is an exponent. So the exponent, I can show an example here. So this is our example here. So the exponent is that our base is 5 and our exponent is 3, which basically comes out to the same thing as writing this. So 5 times 5 times 5. So 5 times 5 is equal to 25, and 5 times 25 is equal to 125. So that's the basics of power math. And as it is right here, we can't really use it for too much, at least not for the example that I want to do now. So in this case we need to understand how we can use this, or the power of power math in our rig, and we need a neutralized value. So in order for you to understand that, so I'm going a little bit backwards here, but it'll make hopefully it'll make sense later on. So right now, imagine the same example, but we have a base, and we have an exponent. In this case, our base is 1, and our exponent is 5, which gives a result of 1, because 1 times 1 times 1 times 1 times 1, obviously, is 1. Which is very powerful, because if I go in here and show you guys the last example, we're gonna try and play a little bit with our spine length. So some of you will know how to increase the spine length through squash and stretch, and other of you won't. But in the part 2 I will go into Maya and show you guys how first of all we set up the stretchy part, and then how we can make this correct squash and stretch. And what we're basically going to do is add attribute values to our multiply and divide nodes, and we're going to set this power system up inside of Maya, because we're going to use this 1 to go into our scale nodes. So in that case all our scale always start on 1 because you don't want scale in your rig from the beginning. So this will always be equal to 1 when it's neutralized, right? Because we usually take the length of our spine and divide it with itself, so that's equal to 1. So if the spine is 2 divided by 2, it's equal to 1, right? Or if the length is 10 divided by 10, it's equal to 1. But as we're increasing the length of our spine, our length will become 11, 12, and as that value gets increased, our attribute value starts to having an effect, because now we're no longer dividing, we're dividing the original length, which in some cases will be 10, divided by 12, and now we no longer have the same value, and then we power that by our attribute. And while this might be a little bit tricky to understand right now, hopefully when we get inside Maya it'll become a little bit more clear, and if you watch it a couple of times, hopefully you'll get a hang of it. Else just mail me or ask questions. Anyways, let's get inside Maya and see if we can figure out how to utilize this. So yeah, that was the first part. Okay, so here we are inside of Maya, and I'm gonna show you now how to set up this a little bit of math for a spline to basically make it a little bit cooler. So as you can see here, I always create some joints and then I delete the last one, because then everything else is sort of oriented after each other. I'm gonna move it up a little bit. Actually, now that we did oriented, I'm gonna move all of them up, so this will be fine. Okay, so let me try and see if I can change the background color so you guys may be able to see a little bit better. So so here we are. I'm gonna try and say so I hold down Alt B to change background color if you don't know that. So I'm creating a spline here, and this is fine. So inside my outliner you can see I get that curve, and I get my IK handle tool or my IK spline. So I'm gonna duplicate my chain. I'm gonna keep the first and the last joint and duplicate it, and the rest I'm gonna delete, because I basically just need these two to control my curve, right? So if I skin that curve now, and I just take the radius up a little bit on these guys, and I move it around, so you can see now that that controls that spline. The next thing I want to do is just rename these, so I'm just going to call this top. I'm not going to stick to a specific beautifully naming convention, but just so you guys can have some idea of like what's what, but I'm not gonna sit and like name everything perfectly, because this will just be like a quick demo. So here it's moving, but the problem is that it's not squash and stretching, and in order for us to even see any movement, I'm just going to build like a quick piece of geometry here that we can sort of measure from. Sorry, so let's try and get that one up here. And let's try and kill the history on this guy and freeze that out. Great. So now we basically have like a base or test material, test object we can use. So the first thing, or the next thing I'll do now that I have my geometry or my character, which is in this case just a pipe, I'm just gonna select my joints here, my skin joints, and hit skin. So when I move my joint around, I get this movement. And next step will be creating two controllers quickly. So I'm kind of like just going fairly fast, like doing all this, you know, the basics that you can also see in the quadruped tutorial, and then I will be going a little bit slower as soon as we go into how we implement the math into our rig. So here are the controllers. I'm just gonna freeze them, and then I'm gonna constrain this stuff up. So parent constraint with a maintain offset on, even though they are in the same position. But here we go. So next thing we do now is this is top controller. Sorry, that's not the top controller. And this is the bot controller. So if I move my controllers around, everything's good. So now the first thing we want to do is we want to create that stretch. and in order to create the stretch we need to get the length of this curve and divide it by itself and take that division and drop that into our scale, because if we divide a value with itself it's going to be 1, and the scale should always be 1, right? And if we make this curve longer, which is basically the curve that's controlling our IK handle, it should divide with itself, and as the curve grows longer we want the value to increase, right? So our joints are scaling like so. So that should actually happen automatically here. So the first thing I'll do now, the next thing I'll do now is just go into my node editor. And here I will select my curve. So if we call this our IK, curve, let's drop that in here, and I don't want only the transform node, so I'm just going to say in and output connections. Or we can actually clean that up and just move that in here by doing so, and we get the original shape. We can use that, but we're going to use this just the shape node. So the first thing we want to do is get the length of that. So let's see. Sorry, we need curve info. And the curve info node take the world position of the points in this curve. So let's try and get the world position here somewhere. So world space here to the input curve. And the way I do this is, so if I just hold down my control and my middle mouse button, I can drag and drop onto whatever I want to connect to, and then I can get the connection editor. So now I want to take this value, this length of this curve, and divide it by itself. So I need the original length, because if I take another length, obviously the division will not equal to 1. So let's try and do that. So let's get the multiply and divide node and get that length. Take the output of this into the input 1x. I don't know, oh, for some reason I dragged it into itself. That was bad. So let's take the arc length here and put it into input 1. So the arc length of the curve info into the multiply and divide node. So this is basically our stretch mold, right? Multiplier. And now we can take the stretch mold and just drop it into our joints, and you'll see that our joints will now scale. So if I go in here and I load up my connection editor here, and if you accidentally closed it, you can go into generals, and there's going to be connection editor right here. So if I take it here and I just load everything up here, and then in the right side, and then you say on the right display, you say only take all these off so we don't see the non-keyables, which means that we're only going to see these values, right? So let's try and pick up the multiply and divide node here and just load that into the left side, and if we go show non-keyables, we can see the output X here. But the first thing we need to do is make sure, first of all, that this stretch mold is set to divide and not multiply, and we need to divide with the same value as the original length, which is the one that we just got here. So we can just take that value and duplicate it, paste it down here, right? And then we take the result of that, so basically the output of that, and drop it into our scale X, and we need to make sure that X is the axis that we're scaling in, and you can see that it is. So my X value here. There you go. So take that X value and drop it into my scale X here, and my scale X in all of these joints. And let's see if that actually works for us, and it does. Perfect. So now we actually have a stretchy spine, which is great. But there's a but, right? Because right now we don't have any volume control. If we scale downwards, it's gonna keep a certain volume. If we scale upwards, it's gonna keep the same volume, and that's not very. It doesn't have any appeal to it. If it's a character, you want the middle of the stomach to go thinner as you squash and stretch them. If you squash them, you want it to go fatter, right? It's just something it's just something that gives like a nice appeal and a certain amount of like believability, no matter if it's realistic or unrealistic. So let's try and build that. So in this case, we use the value that increases as we go upwards, but we want to kind of do the opposite as we go the other way. So I'm going to duplicate this stretch node or stretch mult, and I'm going to rename it to squash mult. And the next thing I'll do now is take this curve info, and I'm basically just going to reverse the value. So in this case, I'm going to drop it into the input 2x, and then on the mult, I'm going to duplicate this value and put it in here. So the output of that would actually go inwards. But the problem is that I could actually just take this value and drop it into my joints, and then I would be done. And as I scale upwards, they would all scale in. But the problem with that is that they would all scale in the same amount. And as this might look correct right now, it's actually wrong, because we want the value in the middle to be a different kind of value than the one above. So even though this looks correct, it's only because of the skinning. But if we really want to make it correct, we have to do our power math. So the first thing we need to do is, we know that in our power math we're going to use the output of this, because this output equals to 1. We've seen that here. This output equals to 1. So we already have our base in our power math. Now we need the exponent. So if we say add an attribute, we're going to say exponent a default value. If I duplicate this name, the default value should be 1.25 maybe. Expo b, default value of 1.5, so the middle one should be the fattest one. Expo c, last one can be the same as the first one, but as you can see, I'm keeping them as attributes, so I can always change them. So let's just keep like 1.2 here, 1.25. Add that. Now we have 3 attributes that we can start using. So in this case, I'm going to load this top controller into my node editor, and I get that here. So now I want to start doing my power math. If I do my power math correctly, we'll see a squash and stretch very soon. So I'm just gonna go in here, I'm gonna type multiply and divide node. And I'm just gonna tell you now, make sure that you change this one to power. And we're gonna call this A, I'm gonna duplicate it, I'm gonna call it B, I'm gonna duplicate it, I'm gonna call it C, right? So now we have one for each of our value. And I'm gonna take my controller here, I'm gonna load in all of these guys. So you can see I have my A, B, my C. And the first thing I want to do here is I want to put in my A into my A, and my B into my B, and my C into my C, all in the first input 1 axis. So that means that all of these values are coming in here. We might have, I actually can't remember right now which one is the exponent and which one is the base here, so we'll see that in a moment. If it's wrong, we can just go the other way. Usually I have this scripted, so I usually don't build it too often, but it's quite a nice trick, so I thought you guys would benefit from knowing it. So let's try and take our squash mold now, and that's supposed to be our base. Actually, I do actually think that we need to put them into the B, but now that we've dropped it or into the 2x, but now that we've already done this, I think we should just try 1 and see what happens. So if I take the output x here of my mold and drop it into my 2x here, and as I move this one, and then we obviously need to drop this A value into one of these guys. So if I say that my first, let's call this the A joint. So I'm not necessarily take the first one, because that can be the hip, right? B and C. So we have a B joint, an A joint, and a C joint. So in this case, I'm just going to do 1 to see how that's going to go. And if it doesn't go the way I think, then we're just going to reverse that quickly. So I'm going to take my multiply and divide node here, and I'm going to load it in over on the left side. And I'm going to take my joint, and I'm going to load it in on the right side. And here we go output and output X, because we're obviously working on the X channels, right? So we want to make sure that we take the output of X channel, and we're going to put that into the scale Y and set. And you can see immediately we're actually having a movement, which is exactly what we didn't want. So you can see we get that value coming in, and that's because these two needs to be reversed, these two values here. So now we know that this is actually the base and this is the exponent, which we probably could have been smart and known from the beginning. But let's just quickly reverse that, no harm in that. And it's good to see you guys see me fiddling around a little bit, because probably like it'll probably even make more sense to see the mistakes and see them corrected. So you can see here I have this connected now to both of them. I only want it to be connected into the right value, and you can see there's happening some stuff to my joint now, because basically it's the equivalent of 0, but that'll be fixed in a second. So if I take, right now I just want to drop this value into all of them. So if I say from B to input B, so I'm going to drag and drop that here. So B to 2x, C to 2x. You can see this one turns yellow because now I have more than one connection coming into these nodes, and it's because this one is basically, the output of this controller is basically going into both input 1 and 2, and we need to get this one, the squash mold, our neutralized spine, which is 1, to be our base, right? So if we take the output X of that and drop that into our input 1x, and do the same thing for this guy, output X, input 1x, do the same thing for the last. Oh, there's some color performance on my graphic card. And let's drop this output X into 1x, and you can see it snap back, because now all the values are 1 again, which is great. And now the last thing we need to do is drop our B value into this joint. So if I take my B joint here and my B multiplier, and I put that output X into the scale Y and Z, because we're already scaling upwards, which is our stretch. Now we're making our squashy part, right? Squash and stretchy part. So I drop that into the other two scale channels, and now take my A, oh that's already connected, take my C and drop it into my C joint. So if I load my joint here, output X into scale Y and Z. So let's just make sure we have all these joints connected. That's all good. And if we select the first joint, second joint, third joint, just say input connections here, we can see if they are indeed fitting, and they are. So B goes into B, C goes into C, A goes into A. Brilliant. And the multiply and divide node is up here going into the rest of them. So now if I select my controller here and I move it upwards, you can see that our multiplier, our scale is actually working very, very smooth, very correctly. And you'll see here that the values are actually different. So hang on, this. Yeah, the sound of London. So you can see that the values that are coming in here are actually different, because these exponents are different. So once we are not stretching our spine, we're basically dividing our spine with its own length, and that's why the input to these guys, as I explained in the arc, as long as the base is 1 and we're multiplying with this value, we're basically just still multiplying 1 times 1, right? It's the same thing. It's the same thing as we saw in the spreadsheet, and we just utilize that. So very, very simple math that can become very powerful and really give our character appeal. And although this is just a simple pipe, you can still see the very smooth movement. And the cool thing about it is that you can change these, and you can leave these open for your animators if you want, so they can actually go in and say like, okay, I actually want them to be a little bit thinner, and he might be like, have a really steady hip, but he's very fat, like in the top here. Or you can even animate him that he's swallowing something that goes through his mouth, right? So it's very, very powerful. But yeah, that's basically how you set up a proper proper spine, or you can use it for spine, tails, whatever you want. It can be used for anything. I use it every time in my rigs. As I said, I scripted it up, so I don't really set up manual stuff anymore, but I kind of like going over it again. Anyways, write to me if there's any problems, and let me know like if you have any questions. Also, remember to go to my website and sign up for the newsletter so I can keep you guys posted every time I have a new video. So that's manuanin.com, and go on the newsletter. I usually send out like a free rig, a very small prop rig that will just keep our animators going, and yeah, I hope you guys have fun, and I hope you really learned something. So yeah, thank you for watching.